Hi everyone, welcome to Vector Database series presented by NexGenAI. In our last video, we saw the literature review of a Pinecone vector database. If you guys have not watched that video, then you should watch it now. And in today's video, we will see the semantic search and how we can do a semantic search using a Pinecone index. And if you guys have not subscribed my channel, then subscribe it first. And with that, let's get it started. So what is semantic search? In traditional search, we use some kind of a keywords to compare them with the actual data points. So if the keywords exist in that data point, it means this data point and is very near to the actual query. But in the terms of vector database search or semantic search, it does not mean like that. So if we draw an index like Pinecone index or some other kind of a vector database index, the information is saved in terms of a vector embeddings. Each vector consists of three things. One is vector ID, which is unique to this data point, and after that the actual vector comes, which consists of the numbers, and after that metadata may come. So a vector consists of multiple dimensions. Like in my case, I have used a vector embedding model which generates the embedding of a data point that consists of 1536 dimensions. Each dimension contains some kind of a attribute related information. And if we talk about overall, a vector embedding preserves three types of information. One is semantic information. By semantic information, I mean what is the actual meaning of that data point. What thing has been described in that vector. The second one is contextual information. So if you use a model like the bird, it saves the contextual information. By contextual information, I mean the information related to the nearby words of a certain word. Like the famous example of a word like bank. The word bank, if it appears with the word like river, it has different context information. And if it appears in terms of some transactions, online transaction, then it means it is a financial institution. So this vector may save the contextual information as well. So the third one is synthetic information. Synthetic information means the information related to the grammar, like what is the main verb and what is its main subject, what is the object. This sort of information is known as synthetic information, and it is also saved inside a vector embedding. So overall, a vector embedding preserves this information. The contextual information may be dependent upon the model that you use for the creating the embeddings. So what is semantic search here? So we have created the vector embeddings inside an index of all our data points. Now it's time to do a query search or semantic search. So in real time, when a query comes, that query is encoded in terms of a vector embedding. This vector is compared or inside with these vector data points by using some kind of a similarity search or distance search technique. Like we can use this cosine search by to check what is the distance between this query search vector and these all the vectors one by one. So if we draw a vector like this is a query vector, and one of the vectors from this index, we can do a cosine similarity which describes the distance between these two vectors. Obviously, this vector consists of higher dimensions like 1536, and I cannot draw it here. So if we consider that the vector consists of two dimensions, then we can compare, or we can do a semantic search to calculate the distance between them. And if this theta or the angle is smaller, it means the two vectors are very close to each other or similar, and that is called the semantic search. So if you visit a Pinecone website and after sign up, then you look this, the interface looks like this way. You have these three things. The list of indexes appears here if you have some created some index, or you can index by clicking on this button. There is a collection tab. Here you can create the copies of your indexes in case of emergency if your data is near to lost. If you have want some kind of a backup, then you can create a collection of that index here. Here is the API keys. You will be given by two things, like one is the environment where your index or your pod will be saved, and there is one some secret key provided by the Pinecone. So these are the things. And other than that, if you visit the Pinecone pricing, this page pinecone.io/pricing, then here you can see the pricing plan for your needs as well. So if you see the standard, choose the standard plan, and the cloud provider, like I choose the AWS. Port type, I described them in my last video about the ports. So if I use the S1 port, and if I use the two number of ports for my needs, then you will instantly be given with the price of per month. Like here, $160 per month you will be charged by the Pinecone. Yeah, so these are the some details about the pricing of a Pinecone index. So let's walk through the code. First, we will mount our drive on which our actual data is saved. After that, we will be needing these three libraries. First one is Pinecone client, which will be used to create Pinecone index and all its related operations. Second one is OpenAI. We will be using the embedding model by OpenAI. The third one is python.env. This library used to import the environment related variables. So now here we will be importing these three environment variables: Open API key, Pinecone API key, and the Pinecone environment that I mentioned earlier in my video. Yeah. So in our data will be related to the properties, and this data will contain four informations, like property ID. What is property ID? What is property description? What is property type? And also the price of that property as well. So these four types of information against our each data point will be used. Yeah. So we have, if I print out the first five data points, uh, it will look like this one. We have these four columns. Okay. So the property description will be used inside our embeddings. So when a real-time query will come, the vector embeddings of that query will be compared against the vector embeddings of property descriptions. So yeah, so other than that, the property type and prices will be saved as metadata in our Pinecone index. So there are two types of properties. One is house type, the second one is duplex type. So we will be distributing our data based on the property types. So total there are 27 number of properties inside our data, and since our data contains two types of properties, one is house type and the second one is duplex type. So we will be creating two namespaces. So I mentioned in my earlier video what is namespace. So namespace is some kind of a data distribution. If you want your data to be distributed in a certain numbers like 1, 2, or 3, then you can leverage the namespace concept in Pinecone index. In our case, there are two types of property types, so we will be creating two namespaces. One is house namespace, and the second one is duplex namespace. Yeah. So now here we will be first creating our Pinecone index. First, pinecone.init will create our connection, and the pinecone.create index will be creating our Pinecone index with the name property search index. So in our index, each data point will have a dimension of 1536, and the type will be used. Index type will be the approximated type. So let's create the index. It will take some time to create this index. So in the third step, we will be preparing our embedding model, which will create all the embeddings in our data. So we will be using test embedding ADA 002 from the OpenAI. Let's run it. So now here we have to convert all our data into this format. So what is this format? Now it's time to insert all our data points inside this created Pinecone index, and in for inserting the data in our Pinecone index, it should be consist like this way. It should be a list of tuples in which the first element would be the vector ID. It should be a string, then the actual vector embeddings of that data point will come. And if we see down here like this way, there should we can also insert the metadata along with this vector. So the metadata should be inside a Python dictionary, and overall a data point should be in the form of a tuple, and all our data should be inside a list. So this is the standard format to assert the data inside a Pinecone index. So now here, since we have two type of property types, one is house and the second one is duplex. So we will iterate over all our property data rows of our data frame, and if the property type is house, then we will give a property type like this way using the property ID. Then we will create a vector embeddings using the get embedding function of that property. Then the metadata, which contains the property type and the price related information, this will be inside the meta, will be saved inside this metadata dictionary. So after creating a data point in this format like I described previously, this data will be append inside this list, house data list. So it is the house data list contains all our data related to property type, which is house type. So in this condition, the other property type, which is duplex data, will be saved in the similar fashion, and the data will be appended inside this duplex data list. So let's run it. So now we have two types of data. Here you can see we have the vector ID first, then the actual vector comes, and if we see at last or inside somewhere in our list, we see this is the metadata which contains the property types and also the pricing information. So we have 14 data points which are duplex data, and 13 data points which are related to house data type property type. So here, what we will be doing, we will be upserting all our data point inside our already created Pinecone property search index. So let's run it. It will not take much time, just a few seconds, like 1 second. All your data points will be inserted in your Pinecone index. So guys, up till now we have seen how we can establish and make a Pinecone index, and how we can upload all our data inside that created index. In our next video, we will see how we can do multiple operations on top of a Pinecone index, how we can make a query for semantic search. Till then, see you. Bye bye.